3.
Okay. All right. And we are live. Thanks everyone for tuning in today. So I think this is today's continuation of last talk. The last time it was a little bit more focused on a theoretical aspect of sCrypt. And this time I want to be more practical and hands-on. So probably will involve a lot of demos and screen shares. And if you have any questions, ask anytime. Okay. So I think this talk I will be is for the general audience. So I want to make it as easy to understand as possible. So I can start with the very basic. So just show of hands. How many have tried sCrypt so far? How many? I know Cansado. Okay. Pericta too. Okay, that's good. And okay, let me do some screen sharing. Okay, can you see my screen now? Okay, that's good. So I'm going to walk through the whole workflow to see how do you usually develop smart contracts in sCrypt. So I think some of you may already know some of the steps, so just bear with me here. I want this to be very generic. So first of all, you need a few components to have the whole environment set up. Number one is the so-called Visual Studio Code. It's basically an open source and free IDE from Microsoft. So actually it's only been here around, I think for like 4 or 5 years. I think now it's one, if not the most, if one of the most popular IDE environment out there. So you can go to visual.the-Visual Studio or just Google Visual Studio Code and you can download it as cross-platform. So you can have all kinds of, you can have Linux, you have Windows or Mac, doesn't matter. So once you download it, it looks like something like this. So I think one of the best thing about the Visual Studio Code is it's pretty much language independent. That means it has this so-called extension market. So if you are from other IDEs like Eclipse or whatnot, you can often see this extension is equivalent to the so-called plugin. So basically, you have a list of extensions. You can add whatever language support you want to have. So for example, you can see on my screen here. So for example, you can have C++, you can have C#, you can have, let's say Docker or Git. So for our purpose, we are going to, so basically once you are in Visual Studio Code, this is the main UI. So you can have your project, you can have a search panel. Then you have if you click this one, this is the extension panel. So inside this extension panel, you can search sCrypt and there's only one here. So after you come here, you can just say install because I already have it installed, so I don't have the option. So you can just one click, it will only take you like a minute and then everything's ready to go. Basically you have everything. There's in this one extension, once you click and then everything is ready to go. So this basically lets you have the editor, you have the compiler, you also have the debugger, which we recently launched. So once you have installed the IDE and the extension, so the next step would be how do I get started? So the standard way and the recommended way is to using some kind of we provide some kind of like a templates or boilerplate. You can go to our website. So basically, if you go to GitHub, you can have sCrypt-sv. This is our main homepage on GitHub. So basically, once you go there, GitHub, there's one repo called the boilerplate, and you can git clone it locally, and that's how you get started. So because I already clone it locally. So you can see I already have it boilerplate locally. So I'm going to go through some of what are the file directories. So basically, this is the top level directory. So basically, you have contracts. Mostly two important directories. So first one is contract. That's where your contract reside, and also the test. How do you test your contract? So for example, here I'm going to open one, which is I call demo. So you have a contract folder. There's a demo contract. So demo. I think enlarge it so you can see more clearly. So within this contract, of course, right? It's like any other ID. You can edit, you can comment, you can type. You know, is demo. Play with it, and you can see it has all the standard ID features. For example, if you hover, as you type, you can autocomplete. As I type here, you can choose. And also you can have the typical, you can hover it and you will see, okay, if you hover over some variable or function name, it will show what are the types and a lot of other meta information about the variable. For example, if it's type X here, you see, okay, this is integer, this is the property for the contract. Oh, by the way, I'm not going to dive deep through the specific syntax here, because then you can find all the syntax here. If you go to your browser and type sCrypt, so this is now our official website, sCrypt.io. So we have a new one, but now it just redirects you to the documentation, sCrypt.io. I think I also type in the chat box later. So you can have all the syntax over here and some other examples. So I think you can read later, but I just want to show you how to practically work and code some contract. For example, here I have a demo contract. Basically, you have some functions you can have here. One is called add, one is called subtract. So once you code up, you can have all the you can see it has a lot of language features. For example, all the syntax are highlighted. You have keyword, you have function, you have variables, basically, and also variable. Once you hover it, if you click, you can go to its definition by hovering, and then I think on Windows, we press the Windows sign and the single click, it will take you to where the definition is. Same for methods. So for example, you have a sum method here. So basically this shows you all the arguments and other return types. So if you can also hover it and click it, it will also take you to the definition. So this is the normal standard stuff. So I don't have to spend much time here. Any questions so far? So basically I showed the basic setup. You can download the IDE and install the extension, and then you can download our boilerplate. It's like a standard template you can start from. So basically, once you have the boilerplate, you can change it, you can copy and update it to whatever contract you want to have. Any questions so far? Okay, let's keep going. I think this is a pretty easy stuff. So the next step, usually the next step would be once you have a contract, right? Before you lock up your 1 million Bitcoins into it and broadcast to the mainnet, you probably want to do some tests, right? So that's where we're going next. So basically, for example, we have a demo contract, and then there's a test. So in test, you go to the JavaScript. So this is basically we developed the in-house testing framework where you can test your contract locally. So if you think about contract, is basically you are testing a so-called locking and unlocking script, right? So you want to see whether your desired unlocking script can actually unlock the contract you already deployed. So it involves two transactions. One is so-called locking, the founding transaction. So basically, you have after you compile your sCrypt down to script, you put it in the output and broadcast it online, right, on chain. And then there's another unlocking script, which in the input, it will provide the key to unlock the contract. So for example, our example here, I'm going to show there's another one called demo. So usually when you're for demo contract, there's a demo test here. So we can take a quick look here, around here. So let me move this out of the screen. So for people coming from JavaScript, so this probably looks very familiar to you because this is used the so-called Chai or Mocha framework. So it's very similar. So basically, once you have your contract, it kind of can be reflected or reassembled into a JavaScript class. So for example, demo contract here once you have this template code, you put your contract name here, it will be now as if the contract, instead of in sCrypt, it's almost like now it's in JavaScript. So for example, once you have initialized into a demo, so basically demo contract here now becomes a demo class within JavaScript. So now this is all standard JavaScript code. So for example here, right? So you have a constructor which takes two parameters, X and Y. So you can say, oh, let's create a new object called demo. So basically give you two parameters, 7 and 4, I put here. And once you have this, then you can test it, right? So if I have, basically I have two ways to unlock it. I can call the add function, or I can call the sub function, public function, which is public function. So basically that's meaning each one public function is one way to unlock the contract. So I choose here, for example, if I use add, so what are the information I need to put here for it to successfully unlock, right? So if you take a quick look at this code, so basically give you two numbers and what secret you have to plug in the unlocking script. Basically you have to put in the sum of these two numbers. So in this case, it's 11, right? So, okay, once you have this simple test, what can you do? How do you run it? So it's very, very easy. So just right click, and on the top of the menu, you can see run sCrypt test. Basically right click, and then you click. It will just start running. And when it will finish, it will show up in the output. So basically you have different tabs around below on the lower half of the screen. So basically you have output, and of course you have you have a terminal, right? And once you run it, right click, run test, it will be here, show up in sCrypt. Okay, now it's passing because as I said, right? So this add function basically tells you have to, whatever two numbers you put in here, you have to put the sum here, right? So we can try to change it to say 11, right? It will still pass. So run again. Okay, still pass, that's good. Let me try some other number. Let's say put it 10. What's your guess? If I put 10? So it is supposed to fail, right? Because 7 plus 4 is not equal to 10. So let's run again, just to verify. Run it again. Okay, let's see. See, now it instead of return or pass, it says, okay, in this line, we can go to 14. So based on this line, instead of return true, now this give you false. So this is how you verify before you send it on chain, whether it works, your contracts are right. Any questions so far? Okay.
Right, I've got a question.
Yes.
Yeah. So like you can use multiple inputs to as a locking, well, the
Yes.
unlocking script rather.
Yes.
So say for example, like I'm just thinking, like say if you had a business with so many board directors, and you had a meeting, a board director meeting, and they all, you had to have like 7 out of 10 agree for a motion to get carried forward, or for like money to be
Okay.
released. Say if it's a finance department, so they have to have a certain number. So that type of thing would be perfect for this.
Yes. Yes. So basically, a lot of times, you have multiple ways to unlock it. The easiest, the most typical example is some kind of like lock time, right? So basically, before the lock time expires, you want to have the normal ongoing thing, and then if something, if no, the action is not taken before the timeline, then you have a way to get refund, right? So for example, I'm buying the ICU membership. I could say have a contract. So if I buy 3 months, and within these 3 months, I can take some action. That's good. That's normal business standard. So what if I want to get refund? So for example, say okay, for whatever reason I'm moving out of the country or whatever, I want to cancel it. I want to have another option. Say, oh, if Joe doesn't take the action within this certain time, I want to take my money back. Another, you could imagine, I have another function says, for example, you can say, say refund. So for example, right? So what's inside here? You can say, oh, I need both me, the whoever sent, and Joel to unlock, right? Both of them have to say sign some signature using their own key, right? Of course, as another example you said is board of meetings. So for example, you want to have 7 out of 10 or whatever number you can have. It's almost like a multi-sig. You can also set it up. So yes.
I was just thinking Amazon would love the refund type of model. I could just imagine with Amazon, they do a lot of refunds, like obviously biggest place in the world. Something like that is a killer. It's a proper killer because the time is saved to avoid frauds and whatnot. Okay, I've got another question. Via an app, via a game app, phone app, some type of app, can you see biometrics being tied to unlocking functions? So you might like need the fingerprints of like 3 people or whatever, but would biometrics be able to be tied through and use this?
I think in theory, definitely yes. So basically, I don't know the specific details how that works internally. So I could assume it's kind of like so when you biometric, so you need to, when you want to unlock, you want to make sure whatever the input you can have is the one you expected, right? So I could think of some kind of like you take a fingerprint or whatever, and put in the unlocking script, put in the locking condition. So in the public function, you will just say, oh, this whatever the input is, basically I put my fingerprint, right? I can take that in my app or in my phone as an input. You can say, oh, this needs to match whatever that's locked, right? So in the code, it will look something like you can easily say, oh, this is it's mostly like so fingerprint, right? This is something you expected. So in one of the unlocking condition, you can say something like, oh, I only, when the input, you can have an input here, right? When basically the input is your unlocking script. So you can say this is the fingerprint, and you have to, how do you make sure this two match? You can easily say, oh, this fingerprint is the one I expected. Yeah, this is the basic mechanism.
Just to say, part of my thoughts on the high end is like prison systems and other confirmation systems. If they were able to use a fingerprint, you know, the 2 guards or 2 whatever, and then it's a much more secure system. If it's all done via this, because if anyone's fiddled the system, well, I think it'd be really hard to fiddle it in the first place because it uses money. And but also the second thing is, if anyone did somehow chopped off someone's thumb or something, and then you'd actually be able to see, you know, trace it. Well, not so much in that scenario, but normally you'd be able to trace it whoever's opened the gate or accepted the parcel, rather than people just saying someone accepted it, or you know, as they do. But yeah, so continue. And if just a quick reminder to anyone, if anyone, I've muted everyone, but you can unmute yourself. If you want to ask a question, either use the chat function or unmute yourself and ask. Preferably unmute yourself and ask, because it gets conversation going. Right, over to you. Back to you.
Okay. Okay, Ken?
Can you hear me?
Yes.
So my question is, so you have a in boilerplate, you have a contract folder and test folder, right?
Yes.
So the contract is is it the contract folder is basically locking script and test is unlocking script?
I think the contract is mostly for locking, because that's what get compiled and goes into the locking script, right? But it also give you information, because it's also give you information about how to unlock it, right? Basically, for each function, if you choose any way to unlock it, you have to know the parameters, right? The arguments. So that's also it's not a part of it, but it contains information about unlocking script as well, right? So for the testing, of course, it definitely has the unlocking part, right? Because here you provide, right? You tell which public function, which way you want to unlock, and what are the parameters, arguments you have to. So of course that has the unlocking script, but also if you remember here, before we do anything else, we kind of like convert whatever sCrypt code contract into a JavaScript equivalent. So this part actually is, you can think of as the locking script part as well. So basically when you do this, is equivalent, now you have the locking part as well. So basically this contract you have both the locking and unlocking.
So basically the test one, you kind of like import the contract, set it in the folder, put it in the test, and then you also, so this is lock, and then you are also showing the unlocking part, right?
Yes.
In the test.
Yes.
So
yes,
another question is that so that test script, like this testing folder, we got this case demo.script_test.js, right?
Yes.
Is that file is automatically created once you make a contract? So
no, you have to cover, yes, you have to manually create it. But usually what you can do is, the standard workflow is you copy, right? You copy this demo contract, right? And then you copy the demo sCrypt test.js, and then you edit from there. That's usually that's whenever I do a new contract, I use that way. Or you can directly change as well if you would like, right? Yeah.
And then on the top of the test, sorry, on the top of the test file, you got the like requirements, and this is like a require pass, require try, script test.
Yeah, this is like this is the same for every test. So that's why I call it boilerplate. You don't have to you don't have to change any part of this. The only thing you have to change is tell it which contract file it is, and then what are the parameters. That's it. So you don't, anything else you don't have to change, because this is all standard boilerplate. Because if I show you some more, right? So this is demo, right? You can see some pay to packet hash. So you can see the top. Yeah, it's like a. That's why we call it testing framework. It looks very similar. It's it just change whatever the specific you have. Other parts you have to stay the same. For example, right? This part, all the required, this standard libraries is the same, and also you can see the describe before and all the procedures. What you only have to change your specific contract part. For example, here, which contract file it is, and what are the inputs? No, what are the constructor inputs, and what are the unlocking function name and parameters. So anything else is you don't have to change them.
Okay, I got it.
Does that make sense? Okay, good.
Yeah, yeah.
Any other question? Okay. If not, I go to the next. So I just showed right here when you, of course, if you are like I don't know about you, but whenever I write some code, it will not work first time, right? As I expected. So usually the first time it will fail, either compile fail, which is another story you can try. So basically also you can fail when you write, right? Test, for example, as I showed earlier, you can say instead of putting 11, which is the right number, make it true. What if you put 10? This will fail, right? So then the problem is, how do you find out which part of the contract is wrong, right? That's a typical problem. You are probably not going to get it right for the first time. So what do? You need the so-called debugger. So how do you test with the debugger? Okay, so that's another folder we talk about. We talk about the contracts. We talk about the tests. There's another one called .vs Code. So basically, this is a specific folder that Visual Studio created and uses. So within sCrypt code .vs Code, there's a config file called launch.json. So this basically help you to launch the debugger and put the whatever debugging parameters inside you want. So I put a lot of examples there. So basically, there are two ways you can start the debugger. The first way is you pretty much copy. Let's say I want to start the debug. I want to test the debug contract, right? Because I have multiple contracts. I have to know which contract I want to debug, right? And what parameters I have. One way is you get an existing configuration and you copy and you manually edit, right? So for example, I want to say debugger, I give it a name. So basically there's a bunch of parameters, but I'm going to show you only have to change a few. So for example, you want to have a name. So it says demo 2020, right? And you also have to tell which contract you want to have. What's the path to that contract. And then you want to see, for example, in this case, what is the constructor parameters? So basically when you call the constructor, what are the parameters you have? So in this case, I put 20 and 6. And once you have the constructor, now you have the full locking script, right? Because everything now is known. The contract you can deploy, but then how do you unlock it? You have to tell, right? Unlocking part, you have the two parts, right? First one is which way you want to unlock. So which method you want to call, right? So for example, you can call, say, add. In this case, I put just add, and then again, put the parameters here, which I put 26, right? Let me use this number because previously I put 10, it fails, right? So I can say, I put 7 and 4 here, and I put, let's get it working first, say 11. Okay, now we can start the debugger. How do we start the debugger? So basically go to the left panel again. So I showed you the file one, Explorer, showed the extension one here. That's another one. You see there's a bug. That's called the debugger panel. So basically you click that and there's a drop-down menu. You can go, you can select, we just based on the name. Okay, let me further enlarge it. So you can choose the name, which we just launched as demo 2020, right? You can click, and then you can click start running. Now it's up. Oh, no, this is a compile fail because I just, there's some error. So let's forget this now. That should be get working. You can start debugging now. Okay. Okay, now it's up, right? So if you can see this, this is a very standard, if you use any other debugger, this is very typical. What do you see when you launch it? You can set breakpoints, right? So basically, you can click on the left. You can set the breakpoints, as I said here. And then top here, you can go, you can step in through the code. For example, here, I can say, okay, go to the next step, go to the next breakpoint, right? So on the left panel, you can also watch all the variables here too. So for example, here, X, now it's 7. Oh, this is the contract variables, 7 and 0. So this is the constructor parameter X and Y, as I showed earlier, right? So this is 7 and 4. You can see X and Y is 7 and 4. So now, if I click one more, it will assign this to this dot Y, right? This dot Y is here. So you can now see first now it's 0. So if I step one more, okay, now it gets assigned to 4. Again, once you come here, we put the Z as 11, right? So you can imagine this. Now, once you add this two, it should give you 11. So I'm going to just run all the way to the end. Once you finish, you go to another tab at the bottom. It says debug console. So basically this is all the debug information that will show. Instead of showing the output or terminal, you go to debug console. This is all your debug information here. So basically it says execution successful. That means it succeeded. So basically that's how you launch it. You go to launch.json. You put your config file there, and then you go to debug panel and select the contract you want to debug, and you hit run. So as I showed earlier, if you put 10, you will fail, right? So let's see how this works. If it's 10, how do I debug? If I run it, let me run it first. So you can click here, or you can usually press Control-5 as well. There's a shortcut, basically Control-5. You will run it. Okay, now it will tell you, oh, this fails. So as expected, right? So you can click. It will show you which line. Here is 17. So basically it shows you this check failed because this is 10, right? So how do we debug this thing? We can set a debugger here, debug point. We can say, we can launch again. Oops, now is stop here. We can see that is 10. And if we can, this sum, you can see now this, if you can also hover it and see the value. So you can also see it on the left because this is 7, this is 4. So if you call it, this will give you 11, right? So that's how hopefully help you identify which is going wrong. So you can, in the debug console, there's also a so-called repo. So basically read, evaluate, print, and loop. So basically it's a small kind of a interpreter built in. You can also leverage here. For example, here, I want to see the value, right? I want to see that is 10, right? Whatever I put. I can also see what is my X value here. It's 7. So I can also call, this is very handy if you build, suppose you build a large program, right? Contract. You don't want to redo this everything. You want to see why this fails now. So you can also call function as well. So I want to see what is this value, because this is something not expected. Is okay. Okay, now it says 11, right? But here my z value is 10. So of course this will fail, right? This will help you identify where it goes wrong. Another function you can also have is so-called watch. So basically, there's a big program. There's a lot of variables and expressions. So sometimes you want to focus on specific variables or expressions. So what do? You can say, oh, I want to watch, let's say, I want to watch y, okay? Now it's 4. Let me rerun this again. Let me finish this first, actually. So now it's in debug console. If I run it, this is the last one. So it will say if it fails, right? As expected. Because now the program finishes, you can see all the variable disappear and also my watch variable, because it's not there anymore. So you will also show not a variable. So if I rerun it again, press F5 shortcut. Okay, now it shows back again, right? You can also watch some expressions well if you want. So this help you, for example, this is Y, because let me show the printer stop it here. I can set a break before it gets assigned, right? So this is now is 0 because it's not assigned yet. It's not initialized yet. So if I go one more step, of course, this will change, right? Because now it gets assigned. Any questions so far about the debugging process? I think this is should be standard if you have used any other debugger for any other language, like JavaScript or C++. Okay, it's good, good. So this is another big step. Basically, when your contract fails, this is how you leverage the debugging tool to help you to identify where it goes wrong. And the information you focus on is in the panel called the debug console. So I think I forget one more thing. So basically, previously I said when you configure the debugging, you can copy and paste, but you can also, another way would be, you can also set add configuration. So there's a lot of examples here. So basically add configuration. So you can choose which language you are using. So of course here we are talking about sCrypt, right? So you can say, oh, this is pretty much you give you a standard snippet. So you can further customize. That's another way to do it. So add configuration. So you can copy paste, change from there. You can also add configuration, sCrypt, choose sCrypt to give you a standard template. And then you can put a specific argument inside. Okay. So after I show the debugger, the next, and also the testing. So the next step, right, would be how do I deploy this thing? How does it become real, right? Because if I only play with it locally, I'm not so sure. I want to try it on the live network.
Can I just stop you a second and ask a question? Which
Yeah, sure.
asked, before we go on. What is the difference between a public function and R? Is that and function and R function? I'm guessing in sCrypt. So I'll ask
public
that again
function
and S function. Yeah, S function. Is that what you mean? A normal function. A public
yeah,
function.
normal. Okay. Yeah. Okay. Good question. So a public. So inside the sCrypt for now, there are two types of function. The one is just normal function you define it, right? You basically give some inputs, you compute some number, and you return the output. Another function specific to sCrypt is so-called with a modifier called a public. So basically, that's how public means you can be called from outside, right? In this case, it can be called by broadcasting a transaction. This is, you can think of public function as the unlocking part. It corresponds to the unlocking part. So basically, in the inputs, this is where your locking script is. So basically, if you can go back to this code. So if you look at here, so demo has when you call the public function, it means now you want to unlock it. Each public function is one way to unlock the contract and spend the coin. Does that make sense? So for the normal function without the pub, you cannot call it from externally, right? So the only way you call it externally is by marking it as public. Then that means now you can unlock by calling this public function. You can notice some minor difference here. Basically, for here, it doesn't have a return value, right? So you can think of explicitly, it just give you true or false, because when you unlock, right, it's a binary function, is a Boolean function. You either success or you fail, and that's how you expect here as well. So for example, here, if you add, when you add, say because this sum is 11, so if it's 10, it will fail, right? If 11 will be good. If you put 0, that will give you false. This when you call the public function. Is that clear?
Ken, did that make sense?
I see. So public function, you
unlock.
Yes.
Yeah.
The function is locking one part?
No, function is just it's like a function in any other language. I probably may call it some other name, but that's usually people call it function. So think of function as just function, procedure, routine, subroutine in other language. And the public function is you can almost think of unlock.
Okay.
To unlock.
So when you the basically unlock, like just you're showing there how to like open up this transaction, basically, right? Open up. I mean, like
the envelope, the lock up coins. Yes, how to open it.
Can you use
how to open the
sorry,
envelopes?
okay.
Yes.
Sorry, Ken.
No, go ahead, please.
Okay, can you use multiple public functions as acceptable to the script? So say like I do a locking script and I say like, okay, it's out of 10, there's 10 keys or whatever attached to it. And I will say if number 1, if he accepts, he's got a value of 11. Say if he accepts all things 11, he's got a value of 11. If he unlocks, then fine. And if numbers 5 and 6 unlock and they reach the same value, then that's fine also. So basically, I'd want a system where there's 10 people and one person can unlock it, the chief person in charge, and the two secondary people, if they combine their keys, they would be able to unlock it. And also the third option would be if 9 out of 10, the super majority all agree, and then they can unlock it. So it has 3 options rather, not just,
yes.
But okay, yeah.
Exactly. That's exactly the use case for multiple public functions, because each public function is one way to unlock it, right? So in your specific case, I just write some sample code here. For example, you can have your case, right? You can say, oh, this is the public key, right? You can have let's say public key 1. You can have you can have 2, right? So then when you open it, right, you can say public function. You can say unlock it, right? So you can give your signature. So for example here, right? So let me rename this. So this is say, okay, just give one example, CEO key, right? Okay, the CEO is public key. So you can say CEO unlock here, right? And put a signature. Then you can say, oh, I only need to check one signature because he's the CEO. So I can say sig and CEO public key. CEO key, okay, right? This is one way to unlock it. Or you can say, oh, sorry, forget this. You can also say, if not the CEO, what do I do? I can say others or others, okay. So instead of need one signature, in this case, you need to say 2, right? For example, sig1, sig2. You can say, if not the CEO, you need to add two keys here. 2, 1, and 2, right? So in here, you can say sig1 is the signature for key 1. Not only you need to unlock the first one, you also have to need another additional language put here. Does this make sense?
Yeah. That's really useful. Okay, I've got another question to add on to that one. Can you use the public function to change the acceptable answer? So say if Ken, I'm in partnership with Ken and Ken has got the right to assign a new key holder type of thing. And on Ken's key, he can come along and basically use his public function to change the acceptable function so that the new person could basically get added.
Okay, that's a little bit advanced because now we are talking about basic contract. The basic contract is if we want to, you are saying, for example, you want to, after the contract's on chain, you want to somehow upgrade it, modify it? Is that what you mean? Okay. Yeah. I think for that, you need another way. Okay, let me show you here. So I forgot another website, basically it's a Medium website for sCrypt. So I also talked about it here a little bit last time. So if you go to stateful, so basically you want to have some kind of a state, and then you want to have somebody that can have access to, can modify the state as well, right?
Yeah.
So then it will not be a one-off contract. Basically, once you deploy, you want to change it. So you can specify any arbitrary condition. This is one condition, right? So you can say, oh, I want to add another function here, right? So you can say, for example, I call it upgrade or modify, whatever it's called, upgrade, okay? So again, you can say, I need the CEO's signature, but then I can add another key, right? Say another key holder. I want to say a new one, new employee, right? So you can also do it, say, I can have the CEO's key, and then you can somehow maintain a state because if you use the state for contract concept, you can have maintain a list, let's say a list of employees, right? Because employees come and go. You can, but you need to be the CEO or any other control that can specify who can change this list of employees that's currently at the company, right? So that's another, you can also do it as well, but it's a little bit more advanced though.
Yeah, definitely a lot of business use cases in that. I can see it developing towards that way. Yeah, absolutely. Because it's not just the employee way, but yeah, passing over ownership of like cars and whatnot, having contracts on cars, passing ownership over. Yeah, various other things. I won't say on air. But yeah. Okay. Any more questions? Oh wait, sorry. There's another question. I'll read it out. I'm not sure if it's really a question. So talking on the new contract stuff, that would have to be another contract, surely? Question mark. Once the contract has been published, so to speak, its terms are set. So a new contract could be created that effectively accepts all previous conditions and adds or maybe removes new terms. Well, I'll answer that in part. On the legal side of things, one of the things you'd have to do is have the initial contract stating something like the terms and conditions can change if blah blah blah
subject to change
is met. Yes. Subject to change, or keys may be updated if we rotating through employees, or anything like that, as long as it's said in that initial contract. Otherwise, yes, you could completely do a new contract and void the earlier one if all parties agreed that the earlier contract was void. You can do something like that.
Yes.
Following on from that, so if you had a let's say you've got an original contract and a new contract, and the new contract could add reasons as to why it might be satisfied.
Yes.
Is there a mechanism by which you can revoke the old contract, or would the new contract automatically supersede?
Oh, it will be. That's I think usually when you upgrade it, the old one will fail because it's just within a UTXO, right? So you already spent the first one, so it's gone.
Okay, cool. Thank you.
So that's basically a massive benefit of doing it on Bitcoin and everything, and on the MetaNet, because other people, a number of times cases, it's probably happened a lot where people have come up with old contracts and brought it to the courts and tried to sell off the old contract, and this way you can automatically say no, look,
there's only one latest. You cannot. It's like a crack site. There's only one set of book. You cannot have two books here to cook. So
brilliant.
There's no way.
I'm gonna quickly make a cup of tea. Do you want to continue, or shall I pause it for 5 minutes if anyone wants to have a 5-minute break?
5 minutes. Okay.
Okay, everyone. I'm gonna pause for 5 minutes.
Okay, cool. Okay, welcome back. So in the first part, we talk about some steps. How do you develop a contract? So first, we just showed how to download and install the IDE and the extension. Then we showed how to write some simple contract. And then we showed how to test it, write some test. And then if test fails, we showed you how to debug it using our built-in debugger. So the next part we are going to show is now, once you finish debugging and testing, now it's passed, what do you do? Now you want to deploy it, right? So how do you deploy it? It's also covered part in the boilerplate. So let me show one example. So again, go to test. So instead of going to JavaScript subfolder, we go to testnet. So here, so basically it contains the code that can deploy it and deploy the locking function, the locking contract, and also try to unlock it as well. So it's very easy actually. If you have the boilerplate here, for example, here, you can simply, you only need to change one thing. So basically this will create 2 transactions. Let me move this away. Start the demo. .js. So basically this will create two transactions. Number one transaction will get the contract and put it in the output and broadcast it. This number one transaction is the locking transaction. And the second one will be get the input, the unlocking parameters, and try to span the previous transaction, right? So you have two transactions, one founding, the other one try to unlock it. So it's actually very simple. I wrap it up in a way. So actually you want to, the only thing you have to change is you have to use your private key. Of course, to be safe on the safe side, I only test it in the testnet here. So you can get some, of course, you can get some testnet coins from some faucet, right? I'm not going to cover that part. So basically, suppose now you have some testnet coins. What do? You put your testnet private key here, and then you can write. Let me recover this because this will make it fair. Let me comment this part out because it's not in the original. Let's also stop the debugger. So again, we can go back to terminal panel. We can run this command called basically this. If you know JavaScript and Node.js, so basically this is the small script containing part of the package, like the JSON. This is part of the Node.js environment. So basically it has some scripts. So this one is called testnet. So basically it just runs the demo.js we just noticed. So you can say npm run testnet, and then it will just run the demo.js we specified. So you can say, okay, now hits enter. Hopefully it goes good. Okay, well, now it's good. It says you have two transactions identified by the transaction IDs. Let me enlarge this. So two transactions. It says it's now on testnet. So let's double check, right? So let's copy this unlocking transaction ID, and I already have the what's on chain open up. So you can, yeah, I think people probably are familiar with what's on chain. On what's on chain, you can also choose which network you use. So instead of choosing mainnet, which is by default, I will use testnet because I'm trying this on testnet. So you can put this transaction in ID and then, okay, show now it is actually on chain. Not accepted, but it's in the mempool. So you can see the contract we just had. Actually, this is the spending one. So let's see, I think this is the spending one. So we can see it's unlock this one. This is the locking script. So basically, this is where the contract gets compiled to, if you can see. So you can kind of see it have here 4 and 7 we provided, right? Because if you go to demo.js, we use the same parameters 7 and 4. So you can kind of have see it show up here. And because this transaction now is accepted into mempool, so that means the contract is valid, the unlocking part, right? We can also double check by going to script part. So for example, right, we have 11 here. You see here, this is 11. The previous one is 4 and 7, right? So this pretty much validates this contract now is actually solid. So basically you give it the sum. You put two numbers. Now how do you unlock it? You have to provide the sum of these two numbers to unlock it. So for example, I can give another example if I want to say change this. Of course, this is a little bit more cumbersome than the demo test case because we are talking about the script, raw script here. So bear with me. I think we are doing some SDKs to simplify this, but for now, you got this. And then if I put 10, right? So what's your guess if I try to deploy it again? If I put 10 instead of 11? Anyone guess?
It will fail.
Yeah, okay. But only the one that's trying to span it, right? Because for the logging one, it was always good, right? Because it's
Right, yeah.
So we expect the first one to fail. No, succeed, but the second one will fail. Let's see. Let's double check this. So we can run it again. Okay, the first one is good, as expected. Okay, right, so this is good. Another one will say, oh, it fails because the evaluation, it failed. That's it, again, that's expected, right? So this give you the whole, again, as I said, this is pretty much when you run the command, npm run is just a wrapper. So it actually run whatever the command is here, right? So this is the actual command that's run. So we can also, instead of using the wrapper, we can also just directly run this command as well. So basically, we run this testnet script, demo.js. We can also run it from here. Okay, now again, it's good again because we just changed back the numbers. We can also double check this again. Testnet. Okay, now it's in the mempool. We can also check see some of the, you see, put 11. And we can also see the previous one's script as well, which get compiled down to this. Okay, so if you want to, again, it's like any other template, you can either modify this existing demo.js or some other examples we provided, or you can just copy and get a new version and start from there. The only thing that everything is out of the box, except you have to provide the private key, right? I'm guessing you guys know how to get some test coins from testnet. So that's pretty much the whole workflow. So basically, now once you finish testing locally, you're very confident now that the contract's working as you expected. Now you further want to further try it, you can, as I demoed here, you can use this examples in testnet folder, and by providing your private key, you can try on testnet as well. Yes, that's standard workflow, the last part. Of course, if you're talking about real mainnet thing, I think you can easily change one parameter, basically switch from testnet to mainnet, and then you are ready to go. But of course, before you do anything on mainnet, you have to, usually the order is you test it locally by writing a lot of test cases to make sure it's working. And then once it's working locally, you can try testnet. And if it's testnet is working, then you are very confident it's going to work on mainnet as well. I want to emphasize one point here. What's this model, the UTX model versus the account models that a lot of other chains are using? Then I think the number one advantage here is the script, because sCrypt or script is the same thing. It's just an abstraction. Right? Script execution is so-called pure function. So basically, it's like a mathematical function, right? Let's say you have a mathematical function called square. You give it 2, it will always give you 4, right? It doesn't matter when you give it, who does the execution. If it's square, you give it 2, it always give 4, nothing else. The same for script here. For script, you can think of the locking script is a function, right? Actually, literally a function in sCrypt. So it's a function. When you put the parameters in, it gives you either true or false. And the good thing is, it doesn't matter where you run it. The miner run, you run locally, you run on testnet. It doesn't matter where it's run. If it's true, it will always be true. If you give the same parameters to the same function, because everything is deterministic, it's so-called pure. There's no side effect. If it's true, it's always true. If it's false, it's always false. So that's a huge advantage in terms of security. Because for other chain, it has the so-called notion of state. So for example, right, if I call some Ethereum contract function, in this time, it will give me 5. If I use the same parameter, I call it again, it will give me 4. Today it succeeds, tomorrow I write it will fail because, for example, the balance is depleted or some other internal checks doesn't pass. So I think this is a huge advantage. I think people may not have realized the full effect. Basically, this make it pure. So another way to look at it is, if it's a pure function, right? Because then function, a different UTXO that are independent. You can run this massively parallel. You cannot be more parallel than this. Each function is independent of the other, any other function, and doesn't depend on any other external state. So you can run them parallel, all of them together. There's no bottleneck. You cannot be more parallel than this. So that's just more feedback. Okay. So any another question for the deployment of the testnet? Okay, Ken.
Yeah, go on, Ken.
So when you want to send it to mainnet, you say I just need to change the package JSON part, or do I need to specify like API?
I think now I have not exposed it yet. Basically, this use another library. So in that library, it's hard coded. So I can go back. So again, we can go back to the homepage for our GitHub. So basically, there's a library testing. So here, you basically use some what's on chain API internally. So in that, hard coded to be testnet. So you can, if you really want to try it, you can very easily. You go to, because it's a local, right? So you can easily to change it to mainnet. Just change testnet to mainnet. That's it. Of course, you have to put the right key as well. So.
Okay, so that's called node module. Okay.
Oh yeah, node module. You can search sCrypt test. I think is enough people request this. I will put this as a parameter. So you can put the key as well as which network you want to run on. So because for now, I don't want to, reach people's files. I want just hard code it to testnet for now. But if you want, I can easily put another parameter. Say by default is testnet. You can change it to, or even some other network as well. What's that? Genesis, whatever. It's hard coded for now, mostly for security reasons.
Okay.
I have a question or two. I was just thinking about like oracles using it in a sense that, say, an oracle's waiting for a real world event on a government or business platform, like business wills, a will looking at like X amount of newspapers at obituaries, and once they like read 10 times that person X is dead, and then it sends a public function to a locking script, which got sent like years ago by the will maker. And that public function basically unlocks the funds and sends it to whoever the recipient is supposed to be. Something like that, an external real world oracle interacting, would that be possible?
Oh yes, that's basically, yeah, this is a very good use case. It's actually That's a specific name for it. It's called dead man's switch. Have you heard about this concept?
Yeah.
Some people call it a last will. So actually, we already have such concept. Oh, it's already a contract written by Stas. I think he's also in the Slack channel. So basically, we already have a contract. If you can, I think if it's, I don't think he has shared the code yet, but if you Google this smart contract, okay, basically now there are mainly two components. So number one is the dead man's switch, or some people call it last will. So what it does is you have a contract, then you have to periodically spend it, refresh it as a heartbeat to prove you're alive, right? And then if not, then whoever your descendant will be, they were going to spend it. If you are after the timeout, you have not responded. You can say a few times, but in this you change it, right? That's the existing dead man. So you are saying to have some kind of like oracle, like some medical authority or something, they can produce, say, the death certificate, right? For that, you need to so-called, you need to sign and verify on chain. So that's called, we also developed a contract for that. It's called wrapping signature. So basically lets you have that kind of, to have, I can also send this in the, so basically you combine this two. So that existing dead man switch, basically you have to periodically refresh the contract to indicate you are still alive. So you change that condition to some oracle, right? Say government authority. So you need to sign with the key that assigned to them. Public key, right? So for example, this you have a public key for UK, I don't know, whatever health of Minister of Health, whoever it is, can issue that certificate. So basically in the contract, inside of the public function, you can say if this, because you can, when you lock it, when you lock it, you can put the official's public key right there, right? So you can say inside the locking, inside the public function, you can say, oh, you need to require this signature. It is actually from that public key, right? So you use the so-called wrapping signature for this purpose. So once you prove this condition is met, meaning this death is actually now officially dead, right? Or you can say a few times as well. You can add some arbitrary condition. You need to say, oh, you need 2 departments to confirm this person is actually not with us anymore. So you can also add that condition as well. So basically, because it's a high-level language, you can specify any kind of a condition you want to have. And the typical way to get data outside of, because this is the script, you cannot easily go to see outside world. You don't know the weather, you don't know the time. So you need an oracle. And for oracle to provide data, how do you ensure that's real? You need use this technique called the wrapping signature. So yes, I think we have today we have the contract wrapping signature, we have the database switch. So we combine them together to get exactly what you are asking for. I think you have to unmute yourself.
Yeah, I did. My fault. Yeah, along those lines, I was thinking that's an excellent primary use, but also down the line, basic automation and what nowadays we'd probably call advanced AI, but I expect in the future it will be just considered basic automation. In that you have the IoT stuff, the fridge, running out of milk, and then seeing that kind of using that type of technology to order more milk from the Amazon bot, and the Amazon bot then to check your finances, to input, do a public function to your spending grocery wallet of some kind. and that automatically then to do a public function to your buying of new milk, and for there to be like a kind of complete chain reaction, which results in you getting more milk at your front door and it being paid for without the user needing to do anything.
Yes.
But yeah, a lot of this stuff sounds complicated, but down at the end, the user end, I can see some real massive practical use cases.
Yeah,
I think there's a lot more complicated cases as well. Ordering milk is very simplistic, but yeah, so I didn't mean to interrupt.
Yeah, I think, yeah, that's the interesting part, because the way I think of a Bitcoin is because it's kind of it's bits part, right? It's data, information, also coin, right? It's the payment, the money. So a lot of time is you can automate, you can improve the efficiency of things, right? So for example, whatever you just said, right? So it's not that easy to automate everything, as you just mentioned, within the traditional payment method, right? So how do you the payment is really a big thing. So because now we have the information and the coins together. So I mean, yeah, you can easily say you only need one signature, right? So basically, when your fridge detects that you are running out of milk, you will maybe just send you a message saying, "Oh, this is you are running low. Can I order it now?" You just approve, right? With whatever the bioinformatics you said earlier, like a fingerprint, right? Even a face.
Just to mention this one now, because we talked about this before recording, having part of the reason for Bitcoin and MetaNet is having data on chain, so that the transactions aren't just happening, but the information of what is being purchased is also on there. But as we discussed before recording, in a way where only the buyer and seller can see the data on chain, what is actually being transacted. And I'm assuming all of this is kind of very possible in the sCrypt model, in the sCrypt code rather.
Yeah,
including data as well.
Yes, so basically the way I think of sCrypt, a script is for the part you want to minimize. Yeah, if I use the fancy word, trustless. I mean, it's not complete trustless, but if you want to minimize trust of certain transactions between different parties which may not trust each other, right? For example, on the internet, right, I buy something from Nigeria, the prince. I may not completely trust him, right? So if I want to do some kind of like atomic transactions, that's the part the script really shines, right? For example, I show some atomic swap. So you want to, again, it's anyway, when you have do transactions, you have a counterparty risk, right? So you want to minimize that risk. You put the logic, the transaction logic, you encode it into script with some higher level language, for example, sCrypt, then you can be very sure either this transaction go through, both parties are happy, or it doesn't go through at all. So you don't have to trust, because if I pay you first, you may not give me the goods or service. If I provide the good or service, you may not pay me. So I think this is the part I find the script or sCrypt would be most useful.
I'm going to add in there as well, as has been discussed in Slack, one of the things about Bitcoin, it being a chain of electronic signatures, in most countries in the world, e-signatures are upholdable in law. So if you have some form of identity attached to the signatures and what you brought, you can prove that you brought it and that it was yours. Or in the future, we might have, there's different ways of doing identity. In the future, I'm sure people will have, some form attached. And basically, if you're buying goods or signing goods through some kind of sCrypt model or code, and then someone tries playing silly buggers with you, if that data is on chain and you can prove you paid for the service or product, and then it's upholdable in the court of law in most countries.
Mm-hmm. Okay. Yeah.
Yeah. So, anyone questions? We have. No, it's not a question. But okay, do you want to continue? We've been at it for an hour and a half. Would you like to give a summary of what we've discussed, and also how people can get hold of you as well? And then we'll end soon after that.
Okay, so before I do that, any other questions? Or? Okay, so I think if not, I want to ask some reverse this direction. So you guys have been asking me a question. I want to ask what kind of contracts you guys want to see built, or what kind of things features you guys want to see from sCrypt side. What's missing? What can be improved? Anybody? Can?
I personally want to see the token system. Definitely, that's something I'm really doing. And also, well, this is personal things, but I'm working on the Oracle, so
token Oracle. Okay.
I kind of need to figure out Oracle. Yeah, when you're providing Oracle, right? I just wonder how you can monetize that. Like, it seems like it's going to be public information that everybody can access, and everybody can use that as a condition. Then I just wonder how Oracle, service is going to monetize that. This is not necessarily something to do with this script. I don't know, but.
Well, one example, my gaming example, say if you've got like a gambling shop, which obviously makes money through its players gambling and such, and they take a cut, and say you're using 10 oracles, but to get a result accurate, you're saying, right, 9 out of 10 oracles have got to agree with the result. So you would then have some kind of script saying, right, the first 9 out of 10 that do a public function and give a result. If all the results are equal and it succeeds, and then those 9 out of 10 receive some funding back to a payment. I would say a payment because, as we've discussed, it's a static over variable, so you don't have to use a fixed standard long code address to give them paybacks. You just use a paymail to send them a return. Anyway, so those 9 out of 10 oracles, they've been built by, say, 10 different businesses and whatnot who watch gambling sites around the world or whatever. They do the public function. The first 9 gets paid. The 10th doesn't get paid. So it incentivizes like giving a speedy result. And then if it all succeeds and it's 9 out of 10 success, and then the gamblers, whoever's bet on that result, but as we were discussing earlier, needs to be correct and whatnot. The gamblers, then maybe it runs through another script and pays out all the gamblers who equal that result. But that might be on a server backend instead of the script itself. The main script function would be the 9 out of 10 oracles reporting on the gambling result and then receiving a reward. So the incentive there would be to pay people to report good results on the gambling side. If it was like an obituary oracles, someone had developed, then I guess you would pay someone if 20 out of 20 reported back the same obituary, the same person was dead, and then if all succeeded, then every single one of them would receive a payment. And maybe that money for that payment, the obituary watcher might charge a person, £1,000 to set it all up, and then £100 of that goes out to the different obituary oracles, which all report in. And I imagine that all could be automated somewhat in sCrypt, basically through public functions and payments. And then even once the 20 have agreed, then having that reward system, having an incentive system and a reward system, which can all be automated, but using paymail. So otherwise it's just a static address, and that's prone to like hacks and whatnot. I mean, I'm sure there's probably other examples as well where, you know, you'd want an oracle. Gaming oracles might be interesting. Using player ready one is an example. Some line down the future, you might hide specific keys in a game or in multiple games. This is one of the things I love about the gaming potential. You could have a key hidden in as a reward in crypto fights. You could have a key hidden in Bitcoin kitty cats or whatever. And, you know, you could have 10 different games with a separate key each, and you're a separate business providing these 10 keys. And then you've got all those 10 keys, and the oracle, and once someone gets a key, they can go along and put it in. And the oracle will just report back how many keys have been accepted. And every so often do an automatic refresh script, like was discussed earlier. Just checking if all 10 keys have been inputted. And then maybe eventually when all 10 keys are inputted, and then it's like, yay, well done players, this new area opens up, or this treasure chest opens up, and you will get rewarded and sent some value back for all 10 keys being found. So yeah, gaming example.
Yeah, great. I think so here we are only providing the building blocks basically to verify. How do you verify inside script to know the data actually is coming from this real oracle? Or how do you build a real business around this? How do you monetize this? Yeah. So now we just give the building blocks from the script says. So how do you build the whole integrated solution? That needs much more thoughts. But it has the blocks, right? The Lego blocks. You can just assemble them.
Yeah, maybe we could somehow put some kind of condition or something in this. I'm not sure, but yeah, we got to think about it.
What you need is that initial profit model to make it worth it for you in the first place, an incentive system to have whoever, you know, have a reason to develop oracles to work with your business, and then a reward system, and the reward system being whatever you can imagine, really. Yeah, depending on the business model, I guess, it is based on the reward system. Because the reward system could be, yeah, a host of things, like as I was saying, the gaming, or a will being put through, or a gambling thing, or a shopping experience. You know, and to get how some of those shopping discount things is, you know, get 20 vouchers over 6 months if you shop with us for so long. If you have all 20 vouchers, then you get some discount or whatever, some new tier membership. And yeah, you could, I suppose, have that slowly tick over, being refreshed by the business, and oracles accepting customers' public functions as they get these vouchers. Because I imagine it would be voucher forms, and then just saying, yeah, I've got a new voucher, sending it to whatever the oracle, and the oracle ticking it off and, yeah, processing it. But yeah, like I said, Lego blocks. But some of those Lego blocks have got to be profit models, because personally my belief is if you haven't got a profit model, and then you've got to develop a profit model down the line, because otherwise generally no one's going to be bothering to build on it. And also you won't get the competition from other people thinking that's a brilliant idea. Also, other key thing isn't just having a profit model. If people can come up with ideas which just simply make the current models more efficient, like we were talking about the buying a ticket, cinema ticket or whatever, with a debit or credit card, if it's all automated and the security's tighter, there's less fraud, no loss to fraud, less loss to time because of customer service, all of these little things. If you make it more efficient and reduce the expenses and the loss, and then that's still increasing the profit models. So it's either a case of building them and making a successful business, building them and selling the idea to another business which is already big and successful, or building them as examples so that other businesses come along and say to us, we love that. How do we do that? Like, you know, some of the things we do in the Slack, like tipping and etching. Those are like a couple of great examples. If every Slack had like a tipping and etching model, I think that could be quite useful to a lot of Slacks. I think people would like that. And they have a lot of users, but yeah, that's a discussion for another time. But I think things like sCrypt can definitely be used to tie in a lot more things, like the receipt with Baymail, like I was saying, and tying in oracles. Yeah, but it just takes us to build on those Lego blocks upwards and to build something which is, oh yeah, it's another key thing as well while I'm talking about it. A lot of developers tend to build things from their own perspective. We don't, well, I'm not really so much a developer, but a lot of developers don't have this layman's view, to put it politely, a layman's view of what the technology does. So developers, we see, oh look, you can do all of this stuff, and they look at it blankly. And so it's up to a lot of us to try and translate the amazing work which sCrypt is into business use case models and practical examples, not just for businesses, but yeah, government agencies might turn around and say, hey, that's really interesting. Can we use that? Yeah, so it's up to us lot to, the Lego blocks are up here, but it's up to us lot to put them a bit higher. Yeah. Sorry, I babbled on a bit. Would you like any last words?
Just continuing about the oracle, I think I think Parisa also mentioned in the chat. Based in another way, I think this may be a little bit far-fetched, but I just want to, you know, put it outside so maybe some people may pick it up. So think of an oracle, right? Another way to say I'm I don't know, like a weather suite, right? Or some other. I can just broadcast daily, say weather in some location. I just broadcast. So instead of just raw data, I put in a contract. So in the contract, I say whoever use this data, you have to pay this address, this amount, right? So they can, you just keep broadcasting the on chain, right? So whoever wants to use this data, when they refer this in a transaction, right? Because you can specify any condition. You can say, if you unlock this, one unlocking condition is you have to send Ken, right? He provides the oracle. You need to give to Ken, I don't know, 100 Satoshi or something to unlock it. So there's everything is on chain, the data and also the logic part. I don't have to go talk to Ken. Right? That's another. Just some idea on top of my head.
That's amazing. As a point on top of that is health records, global health records. Local general practitioners and doctors, they used to 30, 40 years ago, as we all know, used to just have books and whatnot and have their colleagues in their immediate vicinity. And lately they've got the internet and they've got internal systems so they can contact all the doctors within their local area. But with something like that, I can quite easily see that internationally, if people are saying, this is my data, you can use my data if you pay a little bit, that's brilliant for health research, researchers around the world who are constantly, they have to request permission and get sign-offs and so on to be able to use health data. But if it's people around the world just saying, hey, you can use my data, but you've got to pay me a little bit, that would, yeah, really open it up.
Yeah, Parisa, is that what you mean? Basically, instead of you put the data usage fees inside the contract itself, right? So when you're trying to refer to certain transaction that contains the data, there's a condition, there's a contract, right? Saying if you use my data, you have to pay this much rate. Is that what you mean by Oracle license?
Yes, exactly.
Yeah. So you don't have to worry about everything is automated on chain, the data and the logic as well. Does that make sense, Ken? That's another way. I don't know. I don't have a specific contract in mind, but I think it's doable because we have the push transaction, right? You can know all the transactions, the each part. So you can say this output has to be, right, go to Ken for this much. You can even say 1%, or you can even say 100 Satoshi, whatever you decide.
Yeah, that sounds amazing.
Yeah.
And you can update license if you use MetaNet model.
You can know what?
Update license in the future.
Can you see me?
Okay. Yeah, the price can be from another oracle as well. Yeah, so
I have a last question. Do you know does anybody know the reason to use the chain of R puzzle to that for like Craig was talking about this for some like a distributed timestamp service or something. And
what's your question?
Well, do you know the reason to use the chain of the R puzzle?
The chain of R puzzle. What?
The practical use cases of R puzzle. So you mean like like changing it down the line? Like we were discussing earlier, weren't we, about how or we were discussing something else about how you might want to update a contract and set new parameters. Was it R puzzle you were saying was needed for that? I can't remember.
Not necessarily.
No, yeah, it's probably very separate things, but
when you say R puzzle, what do you mean chain of R puzzle? I know R puzzle. I can give you some example. Is that if that's what you're asking?
Yeah, I think R puzzle contain like each transaction like contained another, so you can see the order of the transaction. I think.
Oh, that's a different. I think you are kind of like mentioning the up push transaction. Basically, you can from script itself you can access the transaction, that information that contains this script is because sCrypt is a separate issue, I think.
Kind of.
Because R puzzle is not related to the up push transaction. It's separate. Are you asking for R puzzle examples or?
Yeah. Well, I mean, my guess was like when you start doing Oracle or something like that, right? You have to show your identity. Also, your transaction is some Oracle needed to be like continuously, right? So you have to show to people, this is data, this is old data, this is 1 day old, 2 days old. It's kind of like I need to connect it, right? So my case is I was putting a transaction ID, putting an old transaction ID in the new transaction. I take old transaction and put it in the new transaction, so you see the link. You know what I mean? So it's like a chain. It's like a blockchain, but just the Oracle chain.
I see. Okay.
But it sounds like using R puzzle to making chain like that is better. Some reason I don't know why, but that's why Craig was talking about many times, and I just didn't know why. So
I think maybe he meant hash chain. You cannot. You meant hash chain, and you publish solution in regular intervals. It doesn't need to be R puzzle chain.
Yeah, I think it doesn't need to be. But
it can be hash puzzle chain.
Yeah.
Hash of the hash of the hash of the hash, and you are publishing in regular intervals.
Yeah,
The solution
that's
to
nice. But maybe there's some other puzzle. If you're using other puzzle, maybe it's easier to, like in this case, like a sCrypt case, this case, like you have to put the private key, one private key. I'll say in my timestamp service I'm making right now is I just using one private key all the time, and I have to kind of well. So maybe if I use it, our puzzle somehow much easier to manage or something. That's I thought. My guess the reason to do that, but yeah, well.
Yeah, I don't see why you put a private key in any case. You should never publish.
I mean, you don't need to publish it, but like it's on your program like that, right? So.
Oh, you never expose because everything in sCrypt will be going inside script, right? And script will be go plain text on chain. So you never want to expose private information on chain unless you want to.
Not on chain, but in your server, you have your JavaScript code like that. Like
that's code. That's not you don't let other people see. This code doesn't go on chain. So JavaScript or any non-sCrypt script, it doesn't go on chain. So you can be, you don't need a private key for that.
Yeah. But if you have to use like one private key all the time for 10 years or 20 years, like it kind of be a little dangerous. So maybe that's the reason, maybe Craig was thinking to use something else to make it a chain. That's I thought, but yeah, I'm sorry. Maybe this is not necessarily connected to sCrypt.
Right. I'm going to end soon. We're going to do a quick conclusion. With again, I'll ask how people can get in touch with you. Also, I'm going to ask if everyone can stick around for just a few minutes afterwards, so I can ask for a bit of feedback quickly back. Okay, over to you. You want to give a quick summary and how to get in touch with you?
Okay, today it's we kind of get through the whole walk through the whole development process with sCrypt, developing smart contracts on Bitcoin SV. We basically showed how you download the IDE Visual Studio Code, and also how do you install the extension. Afterwards, we tried to write a few simple contracts in sCrypt, and then we also showed how do you test it locally, and if the test fails, how do you debug it with our debugger. And once everything is all the tests pass, we showed a way with one change, with one input of a key, you can deploy the contract on chain and then unlock it. We also showed how to verify this on the Block Explorer. So that's the whole process we showed today, and you can find us at sCrypt.io, so basically sCrypt.io. And if you have if you have questions to ask, once you go to sCrypt.io, there's a contact. There's our Slack channel is there. That's our main communication channel, I would say. Just join the Slack channel and sCrypt.io. Thanks for everyone.
Thank you very much. I will be including some of the links and details provided in the topics of the uploaded YouTube video. So please check there if you want to see the links. And thank you very much. I'll be ending this one now.